Alright, so today's lesson is going to be over inscribed angles. Remember that an inscribed figure sits inside of a circle and all of the vertices sit on the circle as well. So if I were to draw an inscribed triangle, all three angles would sit on the circle. So as a refresher, you remember that we talked about central angles. Central angles have a vertex that sits on the center of the circle. So this angle here is the central angle, and it makes this arc here. Now, today what we're talking about is the inscribed angle. Inscribed angle means that the vertex sits on the circle right here rather than on the center. So in the case of the central angle, it was equal to whatever the arc measure was. So if this was 40 degrees, this was 40 degrees as well. Okay? However, in an inscribed angle, if the arc measure is 40 degrees, then the inscribed angle is going to be half of that, or 20 degrees. So before we get too far, let's talk about some vocabulary words. Okay, so again, inscribed angle we have talked about is an angle whose vertex sits on the circle. Okay, the sides are made by chords. I'm going to scroll down a little bit so you can see the rest of the words. If at any time you need to pause and write these down, you're welcome to do so. Now, an intercepted arc is the arc that I make with the angle. So in the previous slide, I showed you that the inscribed angle made an arc of 40 degrees. That was the intercepted arc. That was the piece of the circumference of the circle. Now, an inscribed polygon is a polygon who has all the vertices on a circle. So let's draw a circle. And then let's get a line tool. So I can make any figure I want as long as all the vertices sit on the circle. So I really don't know. Let's make a pentagon. How about that? There we go. So this is a non-regular pentagon, but we know that the pentagon is inscribed in the circle because 1, 2, 3, 4, and 5. All of the vertices sit on the circle, therefore it's an inscribed polygon. We talked about how to inscribe equilateral triangles, squares, and etc. and the hexagon. Now, a circumscribed circle is a circle with an inscribed polygon. So this black circle here is the circumscribed circle. So that's the circle, and this is the inscribed polygon. Alright, so here are the theorems that apply to inscribed angles. First we have, if an angle is inscribed in a circle, then its measure is half of its intercepted arc. Now I briefly mentioned that at the first title slide of this. So this is the intercepted arc here, arc AB. This arc, whatever the measure is in degrees, if I divide that by 2, I'll get the measure of angle ADB. So the measure of angle ADB is going to be half of arc AB. Now, if you take a look here, okay, this is angle ACB. Whoops. Right here. And do you notice that angle ACB makes the arc AB? It intercepts arc AB. Now, if I were to take a look at angle ADB, notice that this angle also intercepts the same arc AB. So let's say that AB is 60 degrees. Then the red angle, angle ADB, has to be half that because it's an inscribed angle at 30 degrees. The green angle ACB must also be 30 degrees because it's the inscribed angle for the arc of 60 degrees. So if two inscribed angles make the same arc, then they have to be the same measure. So in this case, angle C and angle D must be the same measure. Alright, so let's do some examples. First off, it says find the measure of the arc or the angle. So in this case here, we've been given arc XZ. Now we know that the arc is going to be twice the length of the inscribed angle. So the measure of the angle XYZ is going to be 1/2 of arc XZ. And since arc XZ is 140 degrees, half of that is 70. Over here, I've been given the angle, and I want to know the arc PQR. I am not doing so well today, guys. There we go. So I know the angle PQR, if I multiply that by 2, I will get arc PQR. So multiply the angle PSR by 2. Since it is 80 degrees, then the arc PQR must be 160 degrees. So the angle PSR times 2 gives me the arc PQR. Alright, and so here was the second part of that theorem. Remember that when I have two inscribed angles that intercept the same arc, the two angles must be the same measure. So I know if WYX is 62 degrees, okay, then I know that this arc must be twice that, or 124 degrees. I also know that this angle here intercepts the same arc WX, so it must be half of 124 or 62 degrees. Because I know that angle Z and angle Y are the same since they have the same intercepted arc WX. So the answer for the measure of angle Z is equal to the measure of angle Y, which is 62 degrees. Alright, here are 3 questions that I would like you to try on your own. So please pause the video now, look at the previous examples that we've worked together, and solve them. Alright, so let's take a look here. We were given the arc, so to find the angle you divide by 2 or multiply by 1/2, 44 degrees. In the second one we were given the angle, and we need to find the arc, so you would multiply by 2. 2 times 91 is 182 degrees. For question number 3, these were two angles that intercept the same arc, and since they intercept the same arc, their angle measures are the same. I went ahead and showed you that the arc BC is twice 38, which is 76 degrees, but that's not necessary if you understand the second part of the theorem of inscribed angles. Alright, here's some other cool theorems about inscribed angles. If I have an inscribed angle, let's say this angle B right here, notice that it makes the arc AC. And that this arc AC is actually a semicircle, and we know a semicircle to be what? 180 degrees, right? And the reason I know that this is a semicircle is because AC passes through the center of the circle. So if this is 180 degrees, then angle B will be half that, or 90. So B is a right angle if and only if AC is a diameter of the circle. So if the 2 points of the circle, here and here, if I draw a line between them and it's a diameter, then that means that angle B must be a right angle. So notice how there was no numbers in this problem, but I will still expect you to know this arc is 180 and this angle is 90 degrees. Now that being said, we can take a look over here at this inscribed quadrilateral. Now, if I take a look at just 2 portions, let's say angle E and angle G. Angle G is an inscribed angle that makes the arc DEF. And angle E is an inscribed angle that makes FGD as its intercepted arc. Notice that when I look at these opposite angles and their arcs, I end up drawing the entire circle with their intercepted arcs. Now I know that the entire circle is 360 degrees. So that means that the intercepted arcs must be half that, or 180. So that means that angle E and angle G must be supplementary. So this angle here, okay, and this angle here must be supplementary. They must add to 180 degrees because their arcs add to 360. And remember that inscribed angles are half of their intercepted arcs. Now the same works true for F and D. Okay, angle D and angle F are opposite of each other, and therefore they must be supplementary. So a quadrilateral can be inscribed in a circle if and only if its opposite angles are supplementary. So we can say if the angles are supplementary, then the quadrilateral is inscribed. If the quadrilateral is inscribed, then the angles must be supplementary. So let's put that into practice. It says find the value of x. Now notice there are no numbers here. However, we know SV is a diameter. So angle T must be a right angle. And that means that angle T is 90 degrees. So we can set 15x equal to 90. And then, in order to get x by itself, you would divide by 15, and then 90 divided by 15 is 6. So the value of x here is 6. Alright, and last but not least, we're going to use the theorem in regards to inscribed quadrilaterals. We know that in inscribed quadrilaterals, opposite angles must be supplementary. So here's angle Z. Angle W and angle Y are adjacent or next to Z. That means angle X is my opposite angle. So 18Y plus 126 must be equal to 180 because opposite angles of an inscribed quadrilateral are supplementary. So all I have to do is solve for y here. Now also, w and y are opposite angles, so 18x plus 72 must be equal to 180 because they are supplementary. They are opposite angles. So why don't you pause and give it a try and see if you can solve for both x and y. Alright, so hopefully you've unpaused the video. Now you're checking your answers. On the red problem with the y, all you do is subtract 126 and divide by 18. To solve for x, you would subtract 72 and divide by 18. So you should get y equals 3 and x equals 6. Alright, that's it for today on inscribed angles. We will continue on our next video talking about other angles. See you then!